Education is one of those things that we tend to overlook, something that we take for granted. Out of the 2 billion kids that reside in this beautiful planet that we call home, half of them live in poverty. That means that the gifts, talents, and skills of a billion kids go to waste. And personally, I believe it's quite concerning. In an interview, Manu Prakash, a professor of bioengineering at Stanford University, explains that in science we have kind of a crisis of accessibility. And his idea, which I firmly stand by, is to make science accessible to everyone. My name is Iñaki Gomez. I'm a life sciences student at McMaster University, and I'm responding to Dr. Prakash's call for action. When we discuss the topic of microbiology, I think it is one of the most important aspects of the biological sciences, as it has an impact in almost everything that we do, from modern medicine to agriculture to our industries. So when I came across Dr. Prakash's work on paper microscopes, I was just simply fascinated. The Foldscope, or the paper microscope, is waterproof, extremely durable, and costs less than $1 to make. And in this hand, which I'm holding, is a paper blood centrifuge, which I actually put together myself. When we combine these two tools, we're not only able to provide kids access to science and an insight to a whole new world that cannot be seen with the naked eye, but we're also able to quickly, accurately, and affordably diagnose diseases such as malaria without the need of being in a lab. When we look at the gold standard for diagnosing malaria, it's to take a blood sample, place it in a centrifuge, which is just a device that spins really quickly to separate the components of blood, and then view it under a microscope to see if the sample contains the parasite. The paper microscope actually folds like origami and can be assembled in less than 5 minutes, for the centrifuge is just made of paper and string and can spin as fast as a $5,000 one. The best part about these is that they're light and they require no electricity. In the next couple months, 26 others and I will be heading down to a remote town in the Dominican Republic, where I hope to be able to bring these items with me to inspire and give young minds the ability to experience science firsthand, to work alongside local healthcare workers, to teach how to use these tools from a medical standpoint, and to just serve the community in whatever ways they need. See, the times when we make the most difference is those when we're able to support one another, regardless if people know each other. It is those times that, although starting small, we can dream big to achieve greater. When we can truly say that we come alive. When we can say that we're one step closer to having science accessible everywhere. You see, when we come together, we can accomplish more. And although you may not be one of those 26 other people, it does not mean you cannot be part of this project. It does not mean that you cannot be part of a community that seeks to better this world. The smallest help goes a long way, and that's where you can join us. Donating $1 means helping the fight at getting rid of the in inaccessibility.